It is prototype of a structure with variation in the angle of inclination for photovoltaic panels. The authors are Herrera-Romero, Escobedo-Trujillo, Alaffita-Hernández, and Morales-Salas, all from Universidad Veracruzana. This presentation includes an introduction, methodology, results, conclusions, and reference. Introduction. According to Muñoz, solar photovoltaic energy is a renewable energy that has seen its price drop in recent years. It has become comparable with conventional energies such as coal and natural gas. Solar energy is a natural resource that benefits countries located in the Sun Belt of the region. As shown in the figure, this area is marked in red. They can be converted in thermal energy via solar collector, as in this image. This is a solar collector, or on electrical energy through photovoltaic cells. This plays a vital role due to the scarcity of non-renewable sources such as oil and gas. Solar energy varies through the years or days. We all know that. Therefore, in the design of photovoltaic system, the angle of inclination of the panels must be optimized to obtain the maximum incident radiations. It might correspond to a large incidence area of solar rays during winter or a smaller area for summer. This means that we take better advantage of how solar rays hitting the panel. The amount of solar energy to a collector resize depends on the following variables. The latitude. The latitude is the position on the Earth in degrees, either towards the northern hemisphere or towards the southern hemisphere of the point we are going to analyze. The day of the year depends on the movements of the relation and rotation of the Earth. Obviously, it gives you the amount of solar radiation that will reach the Earth. The angle of inclination. Depending on the whether the structure is going to be high or lower from the ground. And at the same time comes the solar azimuth angle, which shows which way the solar panel is going to face. We can see this angle in this figure. The Euler angle is also essential from an observer perspective. This angle defines how the sun path changes through the day, and that can path be wider in summer and shorter in winter. Another important variable is the angle of incidence. Is the angle between the sunrise and the normal of the surface. It is directly related to the radiation that reaches the solar panel. Gives you an idea that we have to maximize the incident solar radiation that will reach the panel. Therefore, our objective is to design and manufacture a prototype to mount photovoltaic panels and adjust the inclination angles for different periods. We propose that there should be 7 of these changes throughout the year, and the primary function is to maximize the incident solar radiation. To generate more electrical energy, this change in the inclination angle must be activated manually. Methodology. When installing a fixed collar, the variables that can be controlled are the angle of inclination and the azimuth angles. Let's remember that in the northern hemisphere, a fixed collector is typically oriented toward the equator, which means that azimuth angle is 0. In addition, Duffy and Beckman give us a beginning rules that says to maximize energy through the year, the optimal angle of inclination must have a value equal to the latitude of the place, meaning that the collector will always face the equator and with an angle of inclination equal to the latitude of the place. Around of the world, there are many techniques to reduce the optimal inclination angle. Among them are the following authors. Uh, it is worth highlighting the work previously presented by our group, that of Cruz Hidalgo, which determines the monthly angles of photovoltaic panels facing to the equator. This is done for the city of Coatzacoalcos, which a latitude of 18 degrees. Cruz Hidalgo gives you the calculation to compute the optimal angle for each stage. Based on those optimal angles, we can get the optimal angles for different periods. The periods are weekly, monthly, seasonal, biannual, and annual. In the case of the weekly, the years is divided into 24 fortnights. For the monthly, Clays give you average days for each month, and these are ones that are used to get the optimal angle. In the case of the seasonal, each one corresponds to each season of the year. For the case of the biannual, the first period corresponds to the spring and summer, and the second period corresponds to autumn-winter. In the case of the annual, we get the yearly average. This can be shown in the following figure, where the trend of the daily angles is marked in black, the weekly is in purple, uh, the monthly is in green, the seasonally is in blue, the biannual in yellow, and finally the annual average is in red. As we, as we can see, Jus Adolphi told us the year is equivalent to having the angle of the latitude. Once we have the optimal angles, we compare the annual energy received for different scenarios. Obviously, each scenario with the optimal angle and the values of the other scenarios are shown in the table. What interests us here in the errors we obtain when using the variation scenarios based on the maximum. We can see that compared to the daily, we lost 0.04% of energy on a 40 base. In the month, we lost 0.50. We also see different values for the other case. In the case of the years, we have to say that we lost 6.26%. In the graph, we can see that the daily solar radiation that will reach the panel. Again, we can see these values and the trends of each one of them. Based on this data, we select that we have monthly adjustments. With the monthly adjustments, we can now look for the largest and smallest. The smallest corresponds to June and the largest corresponds to December. From there, we put together similar values. For example, this masked in yellow corresponds to May and June, where we take an average between the two, and it is the angle we will use. Another example is marked in green. It corresponds to April and August. The following image shows the variation of the sun's position through the year and the corresponding angles. The graph shows the trend of the daily, monthly, and prototype scenarios. This is a slight variation between the monthly and the prototype. We start with a prototype already existing for a fixed panel structure. We plan to design a structure that is economical and easily to build. We propose the design shown in the image on the right, where we can see that two tubes with perforation will help you fill the panel, and at the bottom of it there is a rotating mechanism. In the following image, we can see the construction of this prototype. On the right side is the fixed structure and the proposed structure. We can observe again the two tubes have holes on the panel. In the following image, you can see how the structure affixes to the ground. In the upper left picture, we can see the fixed panel in the background. The panel with the maximum angle while in the upper right image, we can see that fixed structures again and the structure with a small angle. The pictures below show that the structures were experimental measures. In one of them, we can see how the sun is hitting the structure greatly intensely with the variable angle, probably around the midway. While in the image of the right, we can see the same structure working possibly at the angle of in the afternoon. Conclusion: the mathematical formulation for calculating the optimal angle of inclination is presented. These angles were obtained for the city of Coatzacoalcos. The periods of obtaining these angles are daily, weekly, monthly, and yearly, where the minimum and maximum values are 4.95 and 41.18 respectively. With the above, we can see that we are correct in obtaining an average equal to the latitude according to the authors. The angle of inclination of the structure that we took into account had monthly variation, and we built the structure based on this calculation. We place it in the city of the Coatzacoalcos, and obviously we observe that these angles have positive and negative values because we are in the tropical regions. This methodology can be applied to build a similar structure that will work in any city as the information of the city in question is used. Finally, I show the reference that we are used during this presentation.